Hello students, now I am taking the Neet 2017 paper code or paper series A. So I am taking the 5 questions, the initial 5 questions. So now I have the question number. One to 5. Now the first question. A potentiometer is an accurate and versatile device. To make electrical measurements measurement of EMF because the method involves now the options. Number 1 option, cells. Second option, potential gradient. And third option, a condition of no current. Flows through the galvanometer. And now fourth is a combination of cells. Galvanometer, and resistance. So now the solution. We know that potentiometer is an ideal voltmeter and it draws no current when it is in balancing position. So ideal voltmeter means that the resistance will be infinite and at that time no current will flow through the instrument, the galvanometer. So what is our condition? The third one, the condition of no current flows through the galvanometer. What we have, the potentiometer. Potentiometer is based on null point condition. It means that no current is taken. In balancing condition. This is the only condition. So our right answer is third one. Answer is third. Now your question number 2. A gas mixture consists of a gas mixture consists of 2 moles of oxygen, 2 moles of oxygen and 4 moles of argon at temperature T. 4 moles of argon at temperature T. Neglecting all vibrational modes. Neglecting all vibrational modes. The total internal energy. The total internal energy of system is now the options. Now first option is 4 RT, second is your 15 RT, and third is 9 RT, and fourth is 11 RT. 11 RT. So now the solution. Internal energy U is equal to 1 by 2 FRT. FRT, this is for 1 mole. For 1 mole. What this formula has been derived, this is on the basis of 1 mole. If suppose we are having the n moles, then we have to multiply it by the n. So U equal to 1 by 2 n FRT for n moles. So now you take, now we are given the 2 gases, one is oxygen and second is argon, and then you find the total internal energy. Total internal energy U equal to U oxygen plus U argon. U oxygen, this is equal to 1 by 2 n, number of moles is 2, F, oxygen is a diatomic gas, so it will have 5 degrees of freedom. So this is now your 5, and this RT plus 1 by 2, n is 4. Argon is given the 4 moles, 4 into, the degree of freedom is 3, and this is now RT. So this will cancel by 2, this 2 and 2 will cancel, So this is now your 5 RT plus 3 to the 6 RT. So total is 11 RT. So here you have to remember that this formula that we study in the theoretical part, this is only for one mole of the gas. So if you want to have this n moles, then just multiply by the n and then find out the internal energy of the system. So you must know the degrees of freedom of the gases, whether it is diatomic, monatomic or the polyatomic gas. So this is the right answer is our this 11 RT. So this is now fourth one. Fourth. And now question number third. Question number third is radioactive material A. Radioactive material A has decay constant constant 8 lambda. 8 lambda. And material B has decay constant lambda. And material B has decay constant lambda. Initially, they have same number of nuclei. Initially, they have same number of nuclei. Same number of nuclei. After what time? After what time? After what time? The ratio of number of nuclei. The ratio ratio of number of nuclei nuclei of material B to material A to material B. Nuclei of material A to material B will be 1 by E. Will be 1 by E. Now our options are, first option, that is 1 by lambda. 1 by lambda. Second is 1 upon 7 lambda. Third is 1 upon 8 lambda. And fourth is 1 upon 9 lambda. This is given to us. So now the solution. And the solution, the what is given in the just we are given the two material A and B. The decay constant of A is 8 lambda and B that is of lambda. So decay constant of material A equal to 8 lambda and decay constant of material B that is equal to lambda. So now we have the exponential law for the decay. Using exponential law. N equal to n naught e to the power minus lambda t. So now we are having the A n A equal to n0 e to the power minus lambda A into t. And for material B, this is equal to n0 e to the power minus lambda B into t. This is given to us. N0 is the same. So this NA upon NB equal to e to the power minus lambda A into 8 into t upon e to the power minus lambda B into t. NA upon NB. This is given to 1 by E. Here given, they are saying after what time the ratio of number of nuclei of the material A to material B. यानी कि that you are given NA upon NB. This is equal to 1 by E. So this is now 1 by E equal to e to the power lambda A. This is now 8 lambda. E to the power, this is now lambda t, or this is now lambda t. So this is e to the power minus 1. This is now e to the power minus 7 lambda t. Subtract. Then what we have? Or 7 lambda t equal to 1, or t equal to 1 upon 7 lambda. 1 upon 7 lambda. So our answer will be 1 upon 7 lambda. This is now second one. Second. So this is direct use of the exponential law of the disintegration of the nuclei. So just you find only understanding point is this one. Though in the real question, this was given that the material B to material A, then we have NB upon NA, that is all by. Taking to this one, this question cannot be solved. So there is what that in place of B there is A, material A, and in place of A there is material B. Then we have this NA upon NB equal to 1 by E. This is the point to understand in the question. And then you can apply this formula and find the right answer. So this is the question number 3. And now question number 4. A U-tube, both ends open. A U-tube, both ends open to the atmosphere. To the atmosphere is partially filled. Partially filled with water. Partially filled with water. Oil which is immiscible. Oil which is immiscible with water is poured into one side until it stands at a distance. Until it stands at a distance of 10 mm. 10 mm above the water level. Above the water level. On the other side. On the other side. Meanwhile, the water rises. Meanwhile, the water rises by 65 mm from its original level. From its original level. See diagram. Here the diagram is given. The density of oil is the option is this is now first I need this this is your so much, this distance is so much, and is 10, and then we have this distance, and then last to this one. This is given the 65 mm, 65 mm. So much is here. This is also 65 mm. So much here. This is now your 10 mm. 10 mm. This is now so much here. And then this is given to, this is now oil, this is water, and what we have, this is the initial. And this is your point A, this is now point B, this is C, D, this is E, and this is F. This is given in the question, and the options are, first option is your 650 kilogram per meter cube. Second is 425 kilogram per meter cube. Third is 800 kg per meter cube, and this is your 928 kilogram per meter cube. So are the options. So now you can have that the both ends of the U2 are open. That means this is now atmosphere. So the atmospheric pressure on the both the sides of this is equal, and then the pressure due to this oil and pressure due to this water must also be the equal, because they are stationary here. So what is the pressure of this one? That is the pressure of this one also. So we have to count the level from this C, because up to this there is oil, and after that we are having this water. So now solution is now the density of oil, and we know the density of water. Density of water. It means rho W is equal to 10 raised to the power 3 kilogram per meter cube. And density of oil, rho oil. This is you have to find. So pressure, the pressure on both sides will be. So now what we have, the pressure rho is equal to HdG, that we know the formula HdG or H rho G. So this H W into rho W into G equal to H oil into rho oil into G. So G will cancel. So this rho oil, therefore rho oil equal to H water rho water upon H oil. So now water level is how much? This is up to so much. So this is only 65 plus 65. This is now 130 millimeter. This is equal to 130. And density that we know, this is now 3. And that of oil, the oil is so much. So 65, 130 plus 10. This is now 140. 140. then you cancel to this one. So this will give you rho W equal to this is your 0.928 into 10 raised to the power 3. So this is your 928 kilogram per meter. So 14 nines are 126. This is now 130. 126. This will cancel by this line. So our right answer is your fourth answer. Such type of question I have told you earlier in the Neet exam question paper. I think this it was 2020. So this is the repetition of that one. Now question number 5. Question number 5 is a 250 turn. Rectangular coil. Of length 2.1 centimeter. 2.1 centimeter. And width 1.25 centimeter. Carries a current. Carries a current of 85 microampere and subjected to a magnetic field of strength 0.85 Tesla. Work done for rotating the coil by 180 degree against the torque is. Now the options. First option is 9.1 microjoule. Second 4.55 microjoule. Third 2.3 microjoule. Fourth 1.15 microjoule. No solution. You have studied in the theoretical part the work done to rotate the bar magnet in a uniform magnetic field. So the formula is that W equal to mv cos theta 1 minus cos theta 2. Now here this n equal to NIA into B into cos theta 1. This is now your 0 degree minus cos theta 2 equal to 180 degree. This is given to us. Theta 1 equal to 0 and theta 2 equal to 180 degree. This is given in the question up to 180 degree. So this will be 2NiAB. And now put the value of all these physical quantities. So this W is equal to 2, N is given to be 250. This is N, 250 turns. I, the current is 85 microampere. 85 micro into IA, area, the length into the width. So this is your 2.1 into 1.25 into 10 raised to the power minus 4. But this is given in centimeter. You have to convert it into meter. A, B. B is given here 0.85 Tesla. 0.85 Tesla. So you multiply all these quantities and you will find it to be approximately 9.1 microjoule. Micro is here, microjoule. So our answer is first. Just to multiply, you will get the so much answer. So these are the 5 questions that I have taken for the Neet 2017, and paper series is A. So you all try to understand all these questions, that how to apply the formula and how to what is given in the question. That it is very necessary to understand the language of the question. Thank you.